Hi, everybody. Welcome to Bitcoin Faculty. I hope you're all having a good day. It's Friday if you're watching the video today. So this is the channel where we're looking at the blueprint analysis of Bitcoin. What makes Bitcoin unique, special, right down to the finest details. We are, of course, continuing with our learning in Python for programming Bitcoin. Yesterday, we covered loops in Python and also Python conditions. I realized though that I totally forgot to do the notes on loops. So we're going to start with a quick recap of what we did, or a summary of what we did on our loops. So let's just open up our screen here. Yep. So let's just take a look at loops here. I'm just going to open it up. See how far we've come with the basics? I'm super excited. That's how much we've done in basically a week. While we wait for this to load, I'm going to just prepare our notes along. We had, if you watched our last video of day 4, we had quite an interesting exercise in loops. Check my stream how. Yeah. Speed test here. Maybe that'll actually wake up my computer. Run. Okay, it's not great. Learnpython.org. This is a free-to-learn Python website if you're interested, and they even have a certificate, which I'm looking forward to getting soon. We are also live every day at this time, so 3:30 South African time. So in Brazil, it would be 10 a.m. In Moscow, Russia, that would be 4 p.m. India, 6:30 p.m. and Hong Kong time, 9 p.m. Okay, we've got our loop up and running. So I'm going to switch over to our notes pad, and we're just going to briefly summarize our loops. So loop, so we learned about the for loop and the while loop. And remember that a loop basically, it will run a block of code. It will then do whatever it's supposed to. So in the examples we were looking at, we were printing different things, different numbers, lists, and then it will go back and it will keep running the code forever and ever and ever till a condition's met. So the for loop works over a given sequence. So for example, a chicken, a list. All right, and then a while loop basically repeats for as long as a certain Boolean condition is met. So remember that when you're coding, you want to at least be able to identify which loop you want to use, the for loop or the while loop. Like, for example, when we wanted to print all the even numbers or the odd numbers in the list, then we used the for list because we had the for loop, because we had a sequence that we were working with. Here on a while loop, it repeats, right, for as long as a certain Boolean condition is met. So, for example, if something is true, it will keep repeating and repeating until it becomes false. We also learned about range functions. Now, range functions, we looked at the start, sorry, it's a comma, not a semicolon, a stop and a step. Remember, the starting point is inclusive. So for example, if this is a 3, it will include the 3. Then if there is a step value, we look at the step value, or in this case, the step value is 2. So it will print out the list, or it will do a range on your list or whatever it is, your data object, in steps of 2, and then you tell it where you want to stop. So for example, if we say stop at 7, this is exclusive, so it will only go up to 5, because it will add 2, which is 5. Now if we add 2 again, we'll get 7, but remember the stop is exclusive. We learned about the break and continue statements. Break and continue. So basically, with the break, we exit a loop. the continue, we skip the current block, and then basically the loop then continues. Whether it's a for or while loop, it will continue. So with the break, you're exiting a loop. In other words, you're stopping it. Because you also don't want a situation like we created a loop that goes forever. And then the continue we used this when we wanted to print even numbers or odd numbers. So what we would tell Python to do is to, let's say we wanted to print odd numbers. Then every time it landed on a block that was an even number, we would tell Python to continue. In other words, and you've got to think this in the context of code. In other words, you don't print this one, you continue to the next block, and then the next block would print if it was, say, an odd number. And the way we got Python to identify even numbers was using the modulo operator, which is this percentage sign, and we say equal 0. So in other words, if there is no remainder, sorry, we added it to here, 2, and then the modulo equals 0. If the number is divided by 2 and there's no remainder, that means it's an even number. I see I've also muddled it up here. So that's not the correct syntax. The syntax would be, so let's say x is the number, then you would say modulo 2, and then you would say, then equals 0. Then don't forget your colon, and then you could either say continue or break. In other words, stop the loop. I see there's also else here. Let me see if I can squeeze it in because it's the only thing left. So if we look at else, remember we used if, elif, and else in our Boolean or our conditions section. In other words, if this happens, which is like a condition, then do this. Else do this, elif do this, and you can keep on listing elif till you get to else. So what happens is for the if condition to operate, it would have to be true, the Boolean value. If it's not true, it will go to elif. If elif is not true, it will, and all of the above are not true, it will then default to else. And remember what we learned about false values. We could also call them falsy values. So anything that is 0 or an empty string or an empty list or anything that is false, like the result turns out to be false. Like if we say 5 is smaller than 3, that's going to be false. Those are all falsy values. So we learned that we can use else for loops. So when the condition of for or while statement fails, the encode part in else is executed. If a break statement is executed inside the for loop, then the else part is skipped. Note that the else part is executed even if there is a continue statement. I can probably better explain it to you if we switch over to our main screen, but let me just write that in, that we can use else for loops. So if we look at our example here, the loop that was created was a while loop, and while count, which at the moment is 0, is smaller than 5, it would print count plus equals 1. So the plus equals 1 means it will keep adding 1. Else print count value reached, and then we've got some string formatting here so that it pulls in whatever the decimal value of count is into the string each time. Because remember, the decimal value is subject to change, so we have to format our string. Otherwise, it wouldn't be practical to have to change your string each time. So if we run the code, it will print 0, 1, 2, 3, 4. So remember, our condition here for our loop is that the Boolean value, right, which is this here, count smaller than 5, it has to be true, right? And it's only true for as long as count is smaller but not equal to 5. The moment it becomes false, then the else statement printed, which is that count value reached 5. Good. So what are we doing today? Today we are looking at functions. Ooh. And I think I'm just going to open it as a new tab. And Python.org. I wonder if it's my browser that is making this so painful, because it works, but I've noticed it gets glitchy when I stay on a tab too long. So functions. 4 more subjects to go, and then we are done with the basics. Oh my goodness. There's data science tutorials, NumPy arrays, pandas, basics, and then advanced. Yikes. I wonder if the test is for like beginner or intermediary. Anyway, I digress. Functions. What are functions? Functions are a convenient way to divide your code into useful blocks, allowing us to order our code, make it more readable, reuse it, and save some time. Also, functions are a key way to define interfaces so programmers can share their code. How do you write functions in Python? As we have seen on previous tutorials, Python makes use of blocks. A block is an area of code of written in the format of, so you have your block head, then you have your colon, and then when you enter, then you've got you can see here it's indented. So first block line, second block line, and so on. So see here this indentation. What I've noticed is that when I type in this on the website, blockhead 2, the moment I use the colon, it indents automatically for me. So I'm actually not sure yet if the software that we use for programming in Python does that automatically, or you might have to press tab. I would think it's probably automatic. So I think the main thing here is you can clearly identify the block because of the indentation. So where a block line is more Python code, even another block, and the block head is of the following format: block underscore keyword, block underscore name, argument 1, comma, argument 2, and so on. Block keywords you already know are if, for, and while. Functions in Python are defined using the block keyword, so inverted commas def, D-E-F, followed with function's name as the block's name. For example, so def, and then my function, don't forget the underscore. So we're effectively giving our function a name. At the moment, there's no, not sure what we would call that, like no inputs. Let's see here. No arguments, that's the word. Print hello from my function. So let's see what happens if we run. I'm going to see if I can try and explain this, but basically what a function does, so we've learned about loops, the for and the while loop, and we've learned about the if, elif, and else statements. The if statement is when we want when certain things happen or certain conditions are met, then something happens. We tell the code or program what needs to happen. And loops allow us to keep repeating basically a block of code. So when it comes to functions, it says here that functions are a convenient way to divide your code into useful blocks, allowing us to order our code, make it more readable, reuse it, and save time. So what happens is, remember I told you we need to always define our variables. And for example, like in a string, you want to be able to format your strings so that it can pull out values from a variable without having to input it manually into your string each time. Imagine you have like 100 strings and you have to do 100 one by one. So that, the purpose of doing that is basically like, if you didn't do that, it defeats the purpose of programming, right? So when we learned if else statements and when we learned loops, we already kind of, I guess, starting to automate our code. Like we're starting to actually do things. But similar to when we format our strings, and we do it so that no matter what value within the variable, whether it changes, the string will update automatically across all the lines of code. The same idea is behind a function. So we've basically been doing like a function with our if-else statement, our loops, but we didn't assign it a value, a variable or name. And that's what we do with the def function. I'm sorry if that sounds weird. It's D-E-F. What we do is we tell Python we are creating this function and this is what it's going to do. And then later on in your code, you can now, instead of having to retype, right, that whole, let's use a loop as an example. Instead of having to retype your loop into whatever you may be trying to do there, you just call your function, right? So number one, you can use your function as many times as you want. You can reuse it because you just have to call on the function, the variable that you've named it, that you've assigned to it. Like in this case, my underscore function. The second thing is it makes the code easier to read because, for example, like I just said, you're avoiding having to retype the whole thing or introduce a function within another block of code. It's just going to make the code unnecessarily long and difficult to read. And it also saves you time because now where you will be using a function, let's say like maybe a couple of times in a line of code, you don't have to write it out each time. You just call on the function. But another thing that's useful about functions, I think, is that we can assign arguments to the function. So for example, here in this my underscore function, these values can change depending on where you are in your code. So for example, here we may want it to print hello from my function. However, later on in the code, we might want it to do something else, but effectively it's running on the same logic. For example, printing a string. And maybe the only thing that changes is like this number in here. Okay. So what a function allows us to do is to have that flexibility with what arguments we're going to put in, and you don't have to keep retyping the logic within your function. You just call on your function, put in your arguments, it will run the code for you. I hope that's a reasonable explanation. So functions may also receive arguments. These are variables passed from the caller to the function. For example, so we have here def, which indicates that we're defining a function, my underscore function underscore with underscore args. Then in brackets, we have our two arguments, username and greeting. They're separated by a comma. So we would print hello, and then remember we use the %s to format the string, okay? As in it's a string value, not a number value, from my function. I wish you, and then whatever your greeting is. So this is exactly what I was saying. Your username might change, right? Or the greeting might change. Maybe it's morning, but later on today, you want to say good evening. Bitcoin. So I'm going to assign values to username and greeting. I'm not sure if we need to do it before or after. Let's try after. So how I would username and greeting. So at the moment, I think we could probably put it in here. Bitcoin faculty. I'll check why that's not working because I'm trying to assign the two arguments a value. Good evening. So let's just see if it prints like it should now. Invalid syntax. Okay. How do I reset it? Whoops. We had username and then we had reset. I wonder if we have to define them within the block of code. Let's try that. Bit of trial and error. Sometimes making mistakes is actually the best way of learning because that's how you remember. Really. Right. Nope. So let's ask. Did I try it here? I think I did. Username greeting. Username Bitcoin faculty greeting. Good evening. Right. Okie dokie, no worries. Is this gonna work or is it gonna give me headaches? I'm very impatient with my internet. Python code. How would I assign a value to username and greeting in this example? If I wanted to do it outside of the code block. You know what I think it will be while we wait? I don't think so. What if I put it here? It's Bitcoin faculty and kind of defeats the purpose because then why are we using a tuple here? It has to be username greeting. Username greeting. So this is our argument. Is it maybe not printing because I haven't told it to print? I say print my function with args, right? tells me invalid syntax. Oh, duh. I didn't put it as a string. Function, my function with args. That's what it printed. You can assign values to username and greeting outside the function and then call the function with these values. Here's how you do it. So you would assign values to variables. So you would say username equals, greeting equals. Remember, it's a string. My function with args, username, greeting. So I'm being silly because it's going to print. So why am I printing again? So, okay. What happens is when you call on the function, right, my underscore function with R, now we can set in our parameters, sorry, our arguments. So I'm just going to paste it, and I'm going to say username, greet, it should print now. Yes. Hello, Bitcoin faculty from my function. I wish you good evening. Okay. So let's go through what just happened. So you use your function def. You create a name for your function. Remember the Python rules for writing. So we use underscore all lowercase, and it's underscore between words. Then in your brackets, you're going to put your parameters. I prefer the situation of rather putting in variables than actual values like a string or a number, because now all we have to do is change one bit of code here, where now we can say a good morning here and our greet name, and it updates without, and I imagine, because practically you might have to run this line of code. These are very simple examples. You might have to run it hundreds of times. So you could not practically update this 100 times. Create your variables, put in your variables as your arguments. Then you set out what your function is going to do. In this case, it's going to print a string. So we put our colon after entering our arguments. It can even be 3. You can put in a number here, 3 arguments. So let's say we can maybe use a percentage D, it's the name, greeting, number, let's just say number, okay? And then over here, we're going to say number equals 30. Number, I don't know why, it's going to read weird. Percentage D, a number is required, not a string. Oh, I got it muddled up. Always read your errors. So remember, I've just muddled it up, that's all. Number's supposed to be in the middle. Username, number, greeting. Username, number, greeting. should work. A number is required, not string. Yeah, it is a number. Username, greeting, number. Hello. Username, number, greeting. Right. Yeah, it worked now. I wasn't following the order, so it was percentage S, percentage D, percentage S. So I had the number at the end of my argument. Then it's got our tuples. So where were we? We were explaining our function. So we created a my function with args. We set our arguments as variables, not values. We want to print something. So we do our print, we format our string. In this case, we are formatting our string to include numbers and letters, or string, sorry. So we have to remember our tuple at the end. And then we need to, in order for this code to work, we need to assign values to our arguments, username, number, greeting. Once we do that, the way we call on the function is now it becomes easy. Now you just type in your function name, my function with args, and you put in your arguments. And those arguments, like I said, they can change, but now it's easier because you don't have to retype all of this. Next time you want to, like I said, say good morning. You just say my function with args. And then I wonder if you can change it probably here too. So Bitcoin faculty, we can change the number to 50, and we can change to the greeting to I wish you a happy Friday. I really do. Hello, Bitcoin faculty. I wish you a happy Friday. So, do you see how easy it is now? Now we've run all this line of code, 4 lines of code in 2 blocks. Of course, you have to define your function, but now going forward, it becomes so much easier. You don't have to in this case because we don't put values in here, although you could. The idea is not to. But in here, you can put values, not necessarily variables like I did here. I still prefer this method because then you only have to change it in one place. And you just put in your arguments, the variables, not the values. Functions may return a value to the caller using the keyword return. For example, define sum 2 numbers a, comma b, return a plus b. Functions may return a value. I suppose it would be simple. What if we do, so let's say sum 2 numbers. I'm not going to define A and B. I'll just say 5 and 5. 10. Okay. So when we didn't have this, it's not going to return anything because we haven't defined our arguments. So yeah, you just, like I say, when you want to execute then your function, you just now, all you have to do is name it and put in your values. You can assign them beforehand to variables, and then you just call on your variable names, or you can put in the values. So there, we got 9. How do you call functions in Python? Simply write the function's name followed by the round brackets, placing any required arguments within the brackets. For example, let's call the functions written above in the previous example. Guys, I think we've been going for 45 minutes. So I try to take a break every 45 to 30 minutes. I know it's a lot to take in, so let's take a short break. I'll see you guys in 10 minutes. Welcome back. Okay, we are looking at how to call functions in Python. So they're telling us that we simply write the function's name followed by the brackets, placing any required arguments within the brackets. For example, let's call the functions written above in the previous example. So we had our first one, which basically had no arguments. Then it was our second one. So that's basically what we did. So if we just say my function, there's no arguments, so it will print hello from my function. In the next example, which is my function with args, we put in the two arguments, which is basically a string, to complete the sentence, which is hello. Then we've got our placeholder from my function. I wish you, and then our placeholder for greeting. So that will print that function. And then for our last example, we had sum two numbers. Our arguments are basically two numbers, A or B. So we can basically now, with this function, we can say sum two numbers and then put in any numbers we want, and it will basically add them up. It will return A plus B. So now we're going to do our exercise. In this exercise, you'll use an existing function and while adding your own to create a fully functional program. Add a function named list benefits that returns the following list of strings: more organized code, more readable code, easier code reuse, allowing programmers to share and connect together. So we've actually got here 4 arguments: 1, 2, 3, and 4 strings. Then we're going to add a function named build sentence, and then our argument is one variable, basically info, which receives a single argument containing a string and returns a sentence starting with a given string and ending with the string is a benefit of functions. Run and see all the functions work together. So we've got here, we're going to define, they've done a bit of it for us. So we're going to define our list benefits. That's the name of our function, list benefits. And we want to return basically these strings. Then it says modify this function to concatenate to each benefit is a benefit of functions. So we've got here, add a function named list benefits. So let's start with that one. Our first string is going to be more organized code. Then we have more readable code. Our third, it's not really an argument, so we're just printing these strings. Easier code use. Remember, our argument is empty here. And the last one is allowing programmers to share and connect code together. Then, so we've done that one. Then we need to add a function named build sentence, which receives a single argument which is basically here benefit, containing a string and returns a sentence starting with the given string and ending with a string, is a benefit of functions. So we want to return then our next one is we're creating another block of code or another function which says name the benefits of functions. List of benefits equals list benefits. For benefit in list of benefits, print build sentence benefit. Name the benefits of functions. So the comment here for build sentence is that we want to modify this function to concatenate to each benefit. In other words, more organized code is a benefit of functions. So return, so we're going to say is a benefit of functions, and then return we've made a list here. So this is where I'm still a bit confused about formatting strings. But I suppose we could try this. We could say list benefits 0 is a benefit of functions. Don't know if that will work. It would be nice if I could print, yeah, it's saying the syntax is not good. So let's look at the next function. Name the benefits of functions. I don't think we need to concatenate it yet. It looks like we're going to concatenate it in this block of code. List of benefits equals list benefits. So we've created, I get it, we've created a new variable, and in that variable we've actually brought in our function over here, which is list benefits. So we're actually inserting this whole line of code. So that's the benefit that we have of creating a function. We've brought in this whole block of code basically into this here. For benefits in list of benefits, print build sentence benefit. So at the moment, it's only saying is a benefit of functions. So it's not including my list benefits. Build sentence, benefit. Build sentence, benefit. Our argument is benefit. We also have a for loop here for benefits in list of benefits list. So build sentence, I think maybe over here we can say list benefits and then 0. Function is not subscriptable. What if we use round brackets? Submit. List benefits, actually, sorry, list benefits is empty. So let's leave it empty. Still doing it. Is a benefit of functions. How are we going to get it to list of benefits equals list benefits I feel like it's something to do here. At the moment, we only returning this is a benefit of functions. Name the benefits of functions. What if I had square brackets here? List benefits 0. List benefits 1. So I'm indexing them. List benefits 2 and list benefits 3. List benefits takes 0 positional arguments, but 1 was given. Yeah, it's true. It doesn't take any arguments. If we look here, we set def and then return. When we use the return, maybe we just wanted to print. We just wanted to print, not return. I take out this and leave it blank as it was. Just trying to built-in function or method object is not subscriptable. Let's look at our examples above. I'm not going to give up too quickly, although I also don't want to take up too much time. The part of coding is problem solving. So we've got our 3 examples up here. Maybe we need to define them to return a list of strings. When we printed turn a list of strings, I want to stick with return. Because I'm pretty sure if I printed list benefits, it would print these strings. Then we need to modify this function to concatenate to each benefit. In other words, the first one on the list is a benefit of functions. So we want to concatenate to each benefit. I'm actually not sure. What if we said percentage %s is a benefit of functions? And then here we create our tuple, right? And we say list benefit. The only thing is I can't remember if when we working with index, if we use square brackets or round. Let's check here. When calling an index in Python from a list, for example, name 0, do we use square bracket or round bracket? Use square bracket. So list benefits 0. For benefits, let's just see what we get. You did not output the correct text. Percentage S is a term, yeah, it's an inbuilt sentence. Function object is not subscriptable. Let's ask ChatGPT what that means. What does this mean in Python? Oops. Sorry. And then greeting. Oh my goodness. Function object is not subscriptable. function object is not subscriptable. Such a fancy word. Typically means that you are trying to use indexing on a function object, which is not allowed in Python. This usually happens if you mistakenly try to access an element of a function as if it were a list, tuple, string, or dictionary. Oh, so I guess we learned something. We can't use indexing on a function object. It's not allowed. Well, how else are we going to concatenate? We would use plus, but we want to return the items one at a time. Return list benefit plus, but you see, this is not a valid string. Is it? Is a benefit of function. And I don't like this way of concatenating. List benefits is a benefit of function. List of benefits equals list benefits. For benefits and list of benefits, print build sentence list benefit. So I'm going to ask for the solution. Okay. Define list benefits. So that part we got right. More readable code. We added all of those strings. I think it's because I used square brackets. So we didn't need to use any brackets. I took the word list rather literally. Then we need to do the build sentence function. So we return percentage %s is a benefit of functions, and then our modular operator is benefit. Oh, benefits is our argument. Whatever's going to fit into here. And this tells us what's going to fit in there. Name the benefits of functions. So that's just the new function that we're creating. It's got an empty argument. Then we say list of benefits equals list benefits equals list benefits. Also empty. Remember, we created list benefits up here. Then we say for benefit, and remember benefits is our argument in build sentence. So for benefits in list of benefits, which is basically this function here, prints, then we're going to print the string. We're going to basically print build sentence benefit. So we've called on our function here, print build sentence benefit. So it might look confusing, but we've defined that function here. So it will, when it picks up this function, it will go here, if you want to see it that way, and it will print the string. More organized code is a benefit of functions. more readable code is the benefit of functions, and so on. So it works, and I mean, I guess I understand it. I do, but I'm a little bit disappointed that I couldn't figure it out. And I think stuff like that, like this, just needs practice. But I'm going to ask ChatGPT to basically explain this in a very simple way. Can you explain this code to me using functions in a simple, understandable, logical way? So we had our first function, which was list benefits. This function is supposed to return a list of strings, each describing a benefit of using functions in programming. However, in its current state, it returns multiple strings as a tuple. We need to modify it to return a list instead. So that is actually where I got stuck, because I realized, and I thought we could bring in the indexing. I realized it's just going to print all of the strings. So I'm just going to ask before I read further. Yes, this is where I got stuck. Why couldn't we use the square bracket to simply create a list? You're correct that using square brackets directly in the list benefits function would have been a simpler and more straightforward way to return a list. Let's explore why the original code returned multiple strings as a tuple, yes, and why using square brackets would be a better approach. Wow, that makes me feel better. I'm joking. Modified code using square brackets, that's the way I had it. Using square brackets explicitly tells Python to create a list with the provided elements. This makes the intention clear that the function should return a list of strings. Here are the advantages of using square brackets to create a list. Clarity. Using square brackets clearly indicates that you are creating a list, making the code more readable and understandable for other programmers. Agreed. Intent. It conveys the intent of the function more accurately, especially when the function's purpose is to return a list. So while the original code using commas to separate strings technically creates a tuple, I didn't know it created a tuple. Using square brackets is the more appropriate and conventional way to return a list of strings in Python. I get it, but would it not have affected the rest of the code functions? No. Show me I'll read it now, how the build sentence and name the benefit of functions would have changed accordingly. So the answer was, if I can just find it. No, changing the list benefits function to return a list using square brackets would not affect the rest of the code or functions. The build sentence function takes a string as input and returns a new string. It doesn't care whether the input comes from a tuple or a list. As long as the input is a string, it works the same way. The function calls lists benefits, yes. So remember this first one, this list of benefits variable called on the list benefits function up here. So the function calls list benefits to get the list of benefits, then iterates over each benefit in the list. Again, whether list benefits returns a tuple or a list, it doesn't matter for this function. It only needs to know that it's dealing with a collection of strings. Let's modify the build sentence and name the benefits of functions to work with the list benefits function that returns a list of strings. Here's how you would change them. So we would format our string with the placeholder, and then we would have benefit. That's it. Does it change? Not really. Doesn't change at all. The name of benefits function also remains the same. So did I just overcomplicate it by thinking I would have to use indexing to call on the elements in the string one by one? I think that's what happened. But at least we know when I created a list, it wasn't necessarily wrong. So this in its current format is basically a tuple. So that's fine. Let's go back to the main explanation. So we understand the first one. Hello, Batman. This sentence takes a string, benefit. So we're looking at this one here. It takes a string, benefit. And returns a new string that concatenates the benefit with the phrase is a benefit of functions. Build says benefit return is the benefits of functions. Yeah, that makes sense. Then the name of benefits of functions function. This function calls the list benefit function to get the list of benefits. So list of benefits, and then we have it here, list benefits. Remember, it's got an empty argument. It's purely designed to return a list. It iterates over each benefit in the list. Okay, uses the build sentence function to build a complete sentence for each benefit. Prints each complete sentence. So a summary is that the list benefits returns a list of benefits related to using functions in programming. The build sentence takes a single benefit string and returns a new string that is a benefit of functions to it. And then the name of the benefits functions calls list benefits to get the list of benefits. Iterates over each benefit in the list and then makes a complete sentence. So there's one thing I don't understand so far about Python, which is like here, benefit. This is just a meaningless word to me. We haven't defined benefit anywhere. So I'm going to say in the build sentence function, I don't understand because benefits is just a word. It was never defined. So how does the code know that a benefit comes from the list in the list benefits function? ChatGPT. There is a free version. But now really, I'm going to lose all my chat history. Or maybe not. Assign values outside code. You need to continue this chat because it uses tools. Are you serious? These people are getting full of nonsense, eh? Now it's just money grabbing. I'm seriously annoyed now. So I'm gonna have to use Aria. Let me just copy. They're going to have to quickly realize, GPT, that there's so much competition. There's no point in what they're doing. Anyway, so in this code, I wonder I can. So I don't understand the build sentence function in that benefit is just a word and it has not been assigned a value. So how does Python know that it needs to, how does Python know to, that it takes a string from the list benefits function? How do the two relate? In the code snippet you provided, the list benefits function returns a tuple of strings representing different benefits of functions. This tuple is then assigned to the variable list of benefits. The build sentence function takes a single argument benefit, that is correct, which is expected to be a string. Okay. In the name of benefits, in the name the benefits of functions function, each benefit from the list of benefits tuple is passed as an argument to the build sentence function. Okay. Python knows that benefit should be a string because when you loop through list of benefits in the name, list of benefits in the name, the benefits of functions function, each benefit is a string from the tuple returned by list benefits. Here's how the two functions relate. The list benefits function returns a tuple of string. The name, the benefits of functions function, calls list benefits to get the list of benefits. It then iterates over each benefit in the list and calls build sentence with that benefit as an argument. The build sentence function takes that benefit and constructs a sentence by concatenating it with is the benefit of functions. Because remember, we used build sentence for the argument benefit. So just to clarify, it looks like Python knows it expects it to be a string. Python knows that benefit should be a string. It seems to also know that this is a list or tuple. For benefits, in list of benefits, print. Okay, that's fine. Then my last question is then I just want to clarify. This is a loop. My understanding is that it doesn't keep repeating to infinity because we are using a for loop that runs over I don't know what the word is, a set of elements in a fixed set of elements in the list benefits function. Am I correct? Yes, you are correct. In the provided snippet, the for loop in the name, the benefits of functions function iterates over a fixed set of elements in the list of benefits list, which is obtained from the list benefits function. Since the list benefits function returns a fixed list of benefits as strings, the for loop will iterate over these elements one by one. Once all the elements in the list have been processed, the loop will terminate. The loop does not continue indefinitely because it is designed to iterate over each element in the list once, and then stop when there are no more elements left to process. So in this case, the loop is finite and will only run as many times as there are elements in the list of benefits returned by the list benefits function. I hope this is also helping you guys. It's certainly helping me to understand. The other thing I'm curious about is why we had to, yes, let me just ask Aria. In the name the benefits of functions function, I see we've also created a variable which then called on the list benefits function. Why was it necessary to create a variable in this case? Could the function simply not have, could the function simply have been called in the next line of code? In the name, the benefits of function, the variable list of benefits is created to store the list of benefits returned by the list benefits function. Cool. While it may seem that the function could be called directly in the loop without storing the results in a variable, there are reasons why it's beneficial to store the results in a variable. So I hope you guys are listening. Readability. Storing the result of list benefits in a variable with a descriptive name like list of benefits makes the code more readable. It clarifies the purpose of that data and its relationship to the subsequent logic. Efficiency. Calling list benefits once and storing the results in a variable is more efficient than calling the function multiple times within the loop. If the function has a costly operation or if the result is needed multiple times, storing it in a variable avoids unnecessary recalculations. Avoiding errors. By storing the results in a variable, you ensure that the list of benefits remains consistent throughout the loop. If you were to call list benefits directly in the loop, any changes to the function's implementation could potentially lead to different results each time it's called in the loop. Debugging. Having the data stored in a variable allows for easier debugging. You can inspect the contents of list of benefits at any point in the code to understand what data is being processed. So basically, I was asking why we created a variable here when we could have just said for benefits in and then list benefits. So those are the reasons why. Let's do a summary on functions. If you're feeling a little bit like this is quite tricky, then I do feel that way too. The only way really around that is to just practice. Start with easy examples, and then yeah, it's a skill, right? To learn the problem solving, to learn the syntax, just the overall structure and the logic, most importantly, it's a skill. So I'm happy that we've understood it, but if you really want to develop that skill, it will certainly require practice. I'll see if I can find a place that offers like more examples, especially where we, writing out the code and actually applying it to problems. So I'm going to switch over to our notes. Hello, it's a Batman. He hates being picked up. I wanted to show his cute face. Okay, let me just open up a new, don't save. Let's summarize what we've learned in functions. So we basically, to create a function, we use the keyword def, and it sounds super weird saying it. So for functions, we have a keyword to create a function so that Python knows, okay, that keyword is def. We then, after a space, we name our function. So for example, let's just check here, my function. Don't forget the underscore. So now this becomes the name of our function, and in brackets we can put the argument. Now from the examples we've seen today, this can be blank, and then we can tell it what to print or what to return underneath. Okay, that's one way. The other way is to put in what I understand is a variable. So my function, right? And if I didn't mention that, sorry, this is called your argument. So my function, and then we can say, let's say name and age. So this function here has two arguments. Let me just move over slightly. So it has two arguments. Now, when we want to call a function, we basically would say my function, and then, so here we could create a string. Before I get to that, print, and then we would say, like, for example, my name is, and you say percentage S. I'm just going to close it there, and then don't forget your tuple. So your tuple would, in this case, be name. And let me just double check that. Yeah. So what happens now is when we call on the function, we would say my function, and then we can, because at the moment it's not going to print anything. This argument, it's just an argument. It doesn't have any value assigned to it. So we can assign the value immediately here when we call on the function. Okay. Or like I said, what's probably a better idea is to assign a value to your argument. And then when you call on your function, then it will pick up, then you would say name here. Then if this happens to change multiple times throughout your code, you don't have a problem because all you have to do is change your variable and this will update. Otherwise, you're going to have to update this each time and actually manually type it in. So it's probably not a good example in terms of like a multiple use case, but I think you get the gist of what I'm trying to say. Like in terms of having code that needs to rerun and rerun, or variables that change, and using code to our advantage, right? So for example, we don't have to fix something 10 times. We only need to fix it in one place. So variables are very important as we discuss towards the end of the section. We also learned about the block code blocks, sorry. So it looks something like this, where you say def, you have your function, okay, you have your arguments, and then you do your colons, and then the next line of code becomes indented. I'm just checking if there's anything else. Yeah, then basically, let me switch over. Basically, our example here, we looked at how within a function, we can call on other functions. And that's effectively the usefulness of functions. It's also why I guess it takes a while to get used to the logic, but when you see that you can just quite easily call in a function, in other words, here, what is in just really one line of code instead of having to retype all of this. Okay, so it's important for very practical reasons. We are going to take our second 10-minute break, and then we will look at classes and objects. And I just want to see something quickly. If it will load. My phone.org. Guys, we're getting very close. So let's push. Let's do classes and objects. And then we will probably wrap it up for today. I'll see you in 10 minutes. Whoops, my mic wasn't on. Sorry, we're back. So we are looking at classes and objects. I'm just going to open a new tab. Okay, it's still busy loading. I'm going to reopen it. Classes and objects. Okay, good. Objects are an encapsulation of variables and functions into a single entity. Objects get their variables and functions from classes. Classes are essentially a template to create your objects. A very basic class would look something like this. So it looks like we use the keyword class, my class. Then remember we're creating blocks of code. So we use the colon. We create a variable with the string blah. Then within that class, we create a function. The argument of the function is self. And the function will print this is a message inside the class. So already in this basic example, we can see how within this class that we've created, we've got a variable and we've got a function. So let's run the code. I don't think it's going to do anything. So let's see what we can do to call this function and also call on our variable. So if I just put here %s for our variable blah, and then in our tuple, we'll just say variable. And then we're going to call on our function, and we'll say function, and then let's say my class. Let's see what happens. So name function is not defined. So perhaps we have to keep it within the code block. Name variable is not defined. It is defined. What if we say, oh, I think I need to indent it again. Let's just try that. So it doesn't do anything. Let's try return function my class. Run. No, it's not working. So let's find out how we would call on this function within a class. So how would we call on this function that is within a class? To call the function within my class, you would first need to create an instance of the class and then call the function using that instance. Here's how you can do it. So I'm just concerned, what I'll do is because you can't see my ARIA screen and ChatGPT's cut me off, so I'll type it in here for you guys. So we have this code exactly as it is. And then it says here, we would say self.variable. We'll find out why. Create an instance of the class. My instance equals my class. My instance dot function. So it's saying my instance equals, so suppose you have to assign a variable to it. In other words, by creating an instance equals my class. The argument is empty, and then we would say my class to call on it, and we would say, no, we wouldn't. We would say my instance dot function. Let's see what happens, and then we'll try and understand it. Okay, it didn't really work. So basically what ARIA says is it added self as a parameter in the function method to refer to the instance of the class. ARIA changed variable to self.variable inside the print statement to access the class variable correctly using self. By creating an instance of my class with my instance equals my class, you can then call the function method using my instance dot function, keeping in mind that function is the name of the function that I created here. So I just want to find out why do you use a dot. So in this case, self dot variable. Python, the dot notation is used to access variables and methods of an object or class. When you use self.variable within a class method in Python, you are referring to an instance variable of that class through the self parameter. Here's why the dot notation is used in this case. Self.variable refers to the variable attribute specific to each instance of the class. Each instance can have its own value for variable. Accessing class members. By using self.variable, you are accessing the class variable through the instance. This allows you to work with instance variables and class variables within the class methods. I think that perhaps it's not, I don't know, understanding the question. So let's read on, because I think, yeah, it's going to explain it further here. We'll explain why you have to include that self as a parameter a bit later. First, To assign the above class to an object, you need to do the following. So, okay, they've done exactly what we did here, where we said my instance equals class. So we've created a variable that refers to the class, and currently it has no argument. Now that the variable myObjectX holds an object of the class myClass that contains the variable and the function defined within the class called myClass. So now we want to know how to access the object variables. Remember, this is all an object. And objects, let's just refresh here, are an encapsulation of variables and functions into a single entity, in this case, my class. Objects get their variables and functions from classes. Classes are essentially a template to create your objects. So I'm still not understanding classes, but let's read on. To access the variable inside of the newly created object, which is this here, my object X, you would do the following. My object X dot variable. So it should, it prints blah. So for instance, the below would output the string blah. Okay, so we're just printing it. My object X equals my class. So now we're just adding print. And now it gives us a string blah. You can create multiple different objects that are of the same class, have the same variables and functions defined. However, each object contains independent copies of the variables defined in the class. For instance, if we were to define another object with the myClass class and then change the string in the variable above. So we've got my object is X, which is my class. Now we've created my object Y, which also refers to this object here, okay, because it's my class. And then if we say my object dot Y dot variable equals Yakety, then we print both values. So it looks like we can basically, using this method, we've basically we've changed the variable, looks like. You can create multiple different objects that are of the same class. In other words, they have the same variables and functions defined. Yeah, because we've taken variable. Notice here that we're referring to variable, so it's the same name here. However, each object contains independent copies of the variables defined in the class. So it hasn't really changed variable here from blah to Yakety. It's just that we have created a copy of it, but it's like an independent copy because we've got my object X and my object Y. To access a function inside of an object, you use notation similar to accessing a variable. So my object X equals my class, and then we basically said my object X dot function. Keeping in mind, don't be confused by the word function here. If this was called name, for example, we would say name here. So it would be my object X dot name. So if we run it, then it prints the function. And the function is to print the string. This is a message inside the class. The above will print out the message. And then we've got init. So before we get to init, let's make sure we understand all of this. So I'm going to try this again. Percentage S, and then we're going to say, I think it didn't work because I didn't close the bracket. So let's run it. See how important syntax is, because like we got this error here, variable is not defined, because we actually forgot our bracket there. So I haven't called on the function. That's why it's not printing anything at the moment. So let's create an instance of a function. So it would be equals message equals, and then we would say my class, my class. Okay, so we have basically created an instance. So we're holding an object in the word message of my class, and then we would say so we first need to create an instance. I'll make notes of this, and then we'll say my class dot message. Is that correct? My class dot message. No, we would say, sorry, we would say function dot message to run the function. Function dot message. Right. Name function is not defined. Does it have to be message dot function? So it's still giving me this weird thing. And if I said just go to where it does function, where is it? You can create to access a function. Yeah, it should be message dot function. So it is not working. Message dot function. We created an instance of my class. We gave it an empty argument. Then we refer to the instance and we say dot name, and it should run the function. So I don't understand why it doesn't work. Oh, I didn't I didn't put the brackets. Let's try now. Run. Variable is not defined. There. We can try this variable equals blah. Let's try now. Unsupported operand type, none type. Unsupported operand type. Maybe we don't need to put brackets because it's only one tuple. Nope. Let's ask Aria. Does this code work? The code you provided has a small issue. The print statements and string formatting are not correctly structured. Here's the corrected version of your code. Just want to go down. Oh, simple little things. The bracket's supposed to go here. Yikes. This is a message inside the class. Blah. Yay! Okay. So obviously I need to do some more practicing on writing in code. But I guess that's why AI is also awesome for us newbies in Python. Okay, so this is an object. We know that much. Classes are essentially a template to create your objects. So I just want to ask Aria here, can you explain to me in simple, wonderful terms the difference between for purposes of objects and classes and Python. It's not really the differences I want to know, but like the different purposes, right? Different purposes. Classes in Python can be thought of as blueprints or templates for creating objects. They define the properties and behaviors that objects of that class will have. Objects are instances of classes. When you create an object from a class, you are creating a specific instance that has its own unique attributes and can perform actions defined by the class method. Here are some basic purposes of objects and classes in Python. Classes define the blueprint for creating objects. They encapsulate data and behavior into a single unit. They allow for code reusability by creating multiple instances of the same class, and they provide a way to organize and structure your code logically. So I think that is what we saw here with classes, where we basically we duplicate the group, and we were able to take the attributes of this group, okay, which is actually, remember the keyword class, okay? We were, so that Python knows it's a class, we were able to take all the attributes of it, meaning all the variables, the functions, and then we were able to manipulate it. For example, changing the variable in my object y to Yakety, but they still remain independent. That's quite interesting. So I'll just repeat that. They allow for code reusability by creating multiple instances of the same class. Objects represent real-world entities or concepts in your code. They have their own unique state while following the structure defined by the class. Interact with other objects and the system by calling methods defined in the class. Allow you to model complex systems by breaking them down into smaller manageable units. In essence, classes define the overall structure and behavior, while objects are specific instances that hold data and can perform actions based on that structure. By using classes and objects, you can create modular, reusable code that models real-world scenarios effectively. So I suppose that's what we did here with the objects. Let's ask Aria for an example. Can you give me a practical example? So what I will do for you guys, I will copy this and let's paste it somewhere here. So we've created the class, it's called car. We have a function. These are arguments. And then we've got self.make, self.model, self.year. And then we've also created just a direct value. In other words, there's no variable for 0. We've created another function in this class, which is to get the description. That just has one argument, self. We return and then we have inverted commas, self.year. Yep, self.make, self.model. We've created another function here and this is all within the class of the update odometer. So we've got 2 arguments. We've got an if-else statement. Okay, so basically if our mileage is greater than equal self.odometer reading, then self.odometer reading equals mileage. This argument over here. Else, print, you can't roll back an odometer. And then we've got your increment odometer. That's another function. We've got 2 arguments, self and miles. And what we do is we take the self odometer and we use the plus equals sign and miles. So let's say if the miles was 10, we would keep adding 10. Remember, we use plus equals 1 to keep adding 1. So now I'll go to the explanation. In this example, we define a car class with attributes like make, model, year, and a method. Get description to return a formatted description of the car. So let's just see here, get description. Yeah, there's the get description. So we'll get to that now. Each time we create an instance of the car class, so car 1, car 2, we provide specific values for the attributes. So now we say car 1 equals car, that's our class here. And then, okay, great. And then what do we do in the brackets here? It looks like we're adding values. We're only adding 3. 1, 2, 3. I think it has something to do with self because we've got the make, model, year. Make, model, year. So we're going to learn what self is. Then we were able to print car 1 dot, and then we call in the function get description. Okay. Same here, car 2 dot get description. The parameters are empty because remember we've defined our values here when we created an instance of the class. Okay. And get description basically by using self is able to access the year, make, and model. So that's why the comment here is that it will print the year first, then the make, then the model. And then just for the fun of it, we've got car1 dot update odometer. And then I see they've put an input there. And also for car 1 increment. So we just look here at update odometer. So we've got self. And then I think the self makes it go back to this data set, right? And it will, this is the mileage basically, 1,000. So that's the argument that's going to be put into mileage. Same with the odometer. So it's got self and then miles, and it's going to say self dot odometer reading again to refer to this set of data here, and then our odometer reading is 500. Because I'm going to ignore that error. So we defined a car class with attributes like make, model, year, and a method. Get description to return a formatted description of the car. Each time we create an instance of the car class, car1, car2, we provide specific values for the attributes. That's correct. So we inputted the year, the make, the model. We can update the odometer reading attribute using the update odometer method and increment it with the increment odometer method. This example demonstrates how classes define the structure and behavior of objects, in this case cars, and how objects, instances of the class, can have their own unique attributes and perform actions based on the class definition. So some keywords here for you guys. This is actually our object, and each object creates a unique, independent instance of this class that we called car. And as stated, they each have their own unique attributes and perform the actions based on the class, what we basically coded in here. So just to try and make sense of it, I'm just going to go over it again because it sounds confusing the first time. So objects are an encapsulation of variables and functions into a single entity. So here, message is an object. I do understand it better now. Message is an object that encapsulates basically the variables and the functions in a single entity called my class. And that's what they say here. Objects get their variables and functions from classes. Classes are essentially a template to create your object. In other words, that's what this example, to be blunt, actually demonstrates. This is just a template. You can see how we haven't actually put in a make, we haven't put in a model, we haven't put in a year. Those are just arguments, and this is where functions come in very useful, because in your function arguments, you don't have to actually put the actual values that you want. You can use it to create a template. So that's how we can use a class to create a template, and then later create an object, which is an instance of that class. And like I said, it will be unique and independent of, so like in this case, we've got car1, car2. So that's actually a nice way of seeing it. It's like a template. We'll explain why you have to include that self as a parameter a bit later. Yes, I'd love to know. First, to assign the above class to an object, you would do the following. So you, just like when you create a variable, you name your variable, and then you say equals, and then you say my class, and then you can leave it empty, like in this case, or in our example, my class, we actually jump straight in. We jump straight into the function. Yeah. No, we created the name of the variable. We said my class, and then in this case, we immediately called on the function car. This is a more of a practical example. To access the variable inside of the newly created object, you would do the following. So then you say my object x dot, and then whatever variable you want to access. Like I said, if this was name, then it should work if I say my object x dot name. So you can see it returned. So for instance, the below would output the string blah. So we had a class with a variable and a function. We created an instance or an object of that class. But first we have to, it's an object, right? But we're creating an instance because we're saying it equals my class, my template that I've called class. And then we're saying print my object x dot variable, and it will print variable. If we say print my object x dot function, it should print the message, which is this is a message inside the class. No, okay. I don't know why I keep getting this error. Let's ask Aria. Maybe I'm doing something wrong again with my formatting. So would this line of code, maybe it doesn't because of the cell. No, the line of code print will not work as intended. The issue lies in the print, the line print my object x dot function. To call a method of an object in Python, you will need to use parentheses after the mentioned name, after the method name. Okay? It's function. So, good. So with variables, we wouldn't put brackets. Functions, remember functions have arguments, so you need to put the brackets. And now print block. You can create multiple different objects that are of the same class, right? Like car1, car2, have the same variables and functions defined. However, each object contains independent copies of the variables defined in the class. For instance, if we were to define another object with the myClass class and then change the string in the variable above. So that I think we understand because we understand now that a class is a template, and by using objects that are an instance of the class, we can basically access the template as many times as we want. And it doesn't affect the class, the variables, or the functions. And then just over here, we talk about accessing object functions. So we've done it. So we shouldn't forget now that when we access the function, functions always have an argument. So don't forget your brackets. We saw from the example that we used that we had arguments. we had the car make model year. But if that's not applicable, like in this case, it's just printing a standard message, you must put in your brackets and just leave them empty. Otherwise, you will get an error. And it works. Init. Okay. The init function is a special function that is called when the class is being initiated. It is used for assigning values in a class. Okay, so let's break this down. Class, and we created a class called number holder. Number holder has two functions. It's using init, and then we've got two arguments because it's a function, self and number. Remember the self, they said they're going to explain to us later on what that means. So we're actually only concerned with the number. Then we say self dot number equals number. So the init function is a special function that is called when the class is being initiated. So we assign values in a class. So if we look further down, it basically looks like self.number, right? Which is this here. So when we call on our argument, we will ensure that we put our number. So remember, we have an object where we create an instance of the class, in this case number holder. However, now we need to assign an argument, which is basically number. Because it has something to do with init. Because normally we would call function and then put the arguments in the function. So we get 7. Print var dot return number, and it will print 7. So let's look at our second function to understand. So we then created a second function. Its return number, it refers to self. My limited understanding is that self has got something to do with this over here, actually, in fact, this number. And so what the function return number will actually do is it will return self.number, which is what we defined here. And effectively, because we've initialized, we've used init, the only argument here is self. So it will automatically draw on the number that we put here. And so when we created our object, which is an instance of a class, and we put in 7, which previously, yeah, we did it there in that example. Then it printed, then we say print, and we say var dot, and we refer to the return number. Return number. So we're calling on this function, the second one, but now we don't have to put in an argument because we've initialized it. Well, first of all, we initialized it here and we put in our arguments over here. So I will ask for a better, simpler explanation. So can you explain to me in simple logical terms the following code in Python? So class definition, we know that. We've defined a class called number holder. It has two methods or two functions. It's got init, which is actually not the way we are used to defining functions. And then we've got return number. Return number, we're very used to that. We've got our name here and then our arguments. The init method is a special method used for initializing objects of the class. It takes two arguments, self, which refers to the instance of the class, and number. Inside init, self.number is assigned the value of the number parameter passed during the object creation. So self.number is assigned the value of the object that is assigned during the object creation. It may help if you're watching the screen at this point. So we created our object here and number will take on 7. If we change it here, it will take on a different number. The return number method is defined to return the value of the number attribute stored in the class instance. Why? Because it takes self as a parameter. So it accesses the instance attributes. It returns self.number, whatever parameter we specified here. An instance or a variable, an object called var of the number holder class is created with the number 7 passed as an argument during instantiation. That is a fancy word. Accessing the attributes. var dot return number is called to access the number attributes of the var object. This method call returns the value stored in the number attribute of the var object, which is 7. Finally, print var.returnNumber prints the returned value, which is 7. So var.returnNumber, it calls on it basically because we've got var, we've got our object, we're referring to our class, so there's the var and the dot. We don't need to put a parameter because we set it with an initializer, as far as I understand, and that's it. Then it prints. In summary, the provided code defines a class number holder that holds a number as an attribute. When an instance of this class is created with the number 7, calling the return number method on this instance returns and prints the value 7. Can you explain to me function a bit better and its practical use. Hmm. The init method, also known as the constructor, is a special method in Python classes that is automatically called when a new object of the class is created. Okay, that makes sense. Okay, it is used to initialize the object attributes or perform any setup that is necessary before the object is ready for use. So I'll just repeat that. The init method, also known as the constructor, is a special method in Python classes that is automatically called when a new object of the class is created. It is used to initialize the object's attributes or perform any setup that is necessary before the object is ready for use. So, for example, let's say we always need to start on the number 7, or it's necessary to have a set number when our class or our object is ready for use. Then we think of it as like an initializer when you initiate something. And so remember, the important thing is that the moment that we assign a new object to the class, instead of having to call on the function like we've been used to doing here, it will basically initiate, or it will be automatically called when the new object of the class is created. And that is why when we created an object of the class, we assigned the value 7. I can quickly go through the practical use of the init method. One common use of init is to initialize the object's attributes with the values provided during object creation, setup, and configuration. It can be used to set up initial states, configure the object, or perform any operations that need to be done when an object is created. Dependency injection. It is often used for dependency injection, where objects or values needed by the class are passed as parameters during object creation. Dependency injection. Yeah, I think it's all saying the same thing. The using init helps ensure that objects are properly initialized when created, reducing the chance of errors due to uninitialized attributes. It promotes encapsulation by centralizing the object initialization logic within the class. In summary, the init method in Python classes is crucial for initializing objects, setting up initial states, and ensuring that objects are ready for use when created. It plays a fundamental role in defining the behavior and state of objects within a class. I'm quite happy. I'd never done classes or objects in Python, so I'm quite pleased to be understanding this. These exercises from experience are tricky, but let's give it a go. We have a class defined for vehicle. So we've specified a class and it's called vehicle. create, oh my goodness. Okay, this should be easy for us. It's basically the example that Aria gave us. Create two new vehicles called Car 1 and Car 2. Set Car 1 to be a red convertible worth $60,000 with the name of Fur, and Car 2 to be a blue van named Jump worth $10,000. So we have class, I'm trying to remember how we're going to do this, how we're going to go about it. The idea is to start with car 1, which equals, and then we're going to refer to the class, and then description. I think the description needs to include the parameters. So is a so first car, so we would start with name, is a time, is a color, kind, worth, value. Then you will say R1 dot description, mean our parameters will be car 1. Well, the name is Fur. The kind of the color is red. The kind, sorry, the kind of the car is a convertible, and it is worth I'm not going to put it in as a number. 60. I'm just going to put it as string because I don't want to complicate it. Okay. I feel like this shouldn't be here because the whole point is to create a template, right? So we're not going to put those values. Whoops. Okay. Then let's do car 2. Car 2 equals vehicle. So we have initialized our class, or we've created an instance of our class. Then we're going to say car2.description. We're going to fill in our arguments. So car2 is jump, is the name. The color is blue. The kind is van. And the value is worth $10,000. Vehicle object, vehicle object has no attribute name. No, because I'm trying to so let's look at our example here. This example used an initializer. No freak. So I'm going to stick with just I get it. But I'm not going to initialize. So we would then say, after setting out our arguments, we need to say self and then refer to the different, the different, we would say self.name equals name. We would say self.color equals color. We would say self.kind equals kind. And we would say self.value equals value. Float is required. No. I'm going to make a percentage S a bit. Description is missing 4 required positional arguments. So I think that's because this is supposed to be empty, part 2. And because we've already set our parameters. Vehicle object is not callable. Vehicle object is not callable. Why not? Probably because it's not initialized. How would we initiate in it? So say in it. Is that how we I forgot my define. Define in it. define in it. Let's try again. Vehicle object has no attribute description. We can probably delete that because it's initializing. But now we don't have a description. So we would just say vehicle, car one, vehicle, and in brackets equals vehicle, and then like that. So actually I can cut this out, Control X, because we're initializing it. And it is called vehicle, yeah, a bit. So syntax error, line 14. Line 14. We forgot. Oh my goodness. Let's try again. The bit. Your code. Oh, object takes no parameters. Object. Does it tell me which line? Looks like 12. Of course it takes parameters. I've initialized it. Because if we look up here, I won't harp on this too much longer. Yeah, I think I haven't done the initialization properly, because then we would say define and probably description, right? And we refer to self, and then we would perhaps return all of this whole string. It's being done so nicely for us. Turn, and we will be returning it. This is where there was a syntax error, so I probably might not be able to go beyond this point, but we can try. Let's try. Object takes no parameters. So I'm going to go ahead and get the solution. I'm not too concerned. The main thing, guys, is that you're not aiming to be top class programmers. We're aiming to understand code, be able to read it, and follow what's happening. And there's always sources that can help us. So that is the goal. So basically, this was correct. So there was no changes here, although I'm not sure why. This looks odd to me. Description, self. So we had a class vehicle, right, which had 4 objects. The moment they just assigned totally random values. Okay, they don't actually, to me, this doesn't look like a good template. Okay, because these numbers are meaningless. They don't relate to the question. It's supposed to be a template. Be that as it may. We then create, within this class, we have 4 variables. Now we're going to create a function that basically will revert to self. In other words, nothing to the instance of the class. And then we create, within that function, we create another variable. And that variable is basically a string, okay? And you can see here in our modular operator, we return to the class, so self.name, self.color, self.kind, self.value. And then we basically, what this function does is it returns that string. We then go to car1. We create an instance of the class, and then we start assigning the values that we really want. So for example, car1.name, we really wanted for car1 to be fur. The color is red, and so on. Car2, remember, we can create multiple instances using objects of a class or template. So car2, we do the same thing. Then basically we are able to print our function within the class. We've already, I suppose, when we created the instance of the object and we were able to manipulate the variables to what we actually wanted, then we don't have to put anything in there because it's already done that for us here. So we just say car1, we call on the description, and don't forget when you're calling on a function, you must include your brackets. And that's it, it's done. Practice is the only way you'll actually get this. But in terms of understanding, and yeah, just try it out, experiment, mess around, then I'm definitely quite happy. So we are going to finish up. It's been quite a long live stream, but I do think it's important we quickly just do a summary. Definitely some interesting things that we learned today. So this is our notepad. Okay, I'm going to try and sum this up as best as I can. So we talked about classes and objects, and basically how they can interrelate with each other. So a class is basically like an entity. It's like a single entity, right? By entity, we have a combination of as many variables as we want and even as many functions. Don't forget your spacing. That's important for Python. Okay. And it's all combined into, like I say, a single entity. What happens is when we have a class, right, which has multiple variables and functions, we can basically assign the class to an object. So let's call it, let's say our class is called Bitcoin faculty. Okay. So in other words, it would look something like this: class, and then Bitcoin faculty. Okay. And we've got our variables and our functions. So now we can basically take that class and we can assign it to an object. So we can say bit, sorry, it's all lowercase, bit students underscore students. And we can say equals Bitcoin. And I'm breaking the rules here. So I'm supposed to use underscore. Equals Bitcoin faculty. Don't forget your parameters. So what we do when that happens is we've basically created an instance of that class. The moment we do that, we can now access variables within this class, any variable we want. So we can say top 100, and we say dot Bitcoin faculty. Okay, and in that way we can access that variable. And I seem to, my object x dot name, I seem to get muddled with this. We would say, we would use the object we created to access the object or the variable we want. So let's say we had a variable within bit students that had a top 100 list of students. So we'd say bit students dot top 100. Let's just pretend here in Bitcoin faculty we created a variable called top 100. Now we can access it. But actually the main point of classes and objects is that basically we can use a class as a template. So if I go back to my Aria, it seems, oh, it hasn't deleted it. So basically, maybe I can move. Nah, let's open a new one. Just center it. Menu, new. Basically, a class can be used as a template or a blueprint, right? creating objects. For creating objects, which essentially the class defines. For example, name, make, model, year. And the great thing is you can create as many objects as you want. Multiple objects of an instance of a class, and they will each be sort of independent. It's not like how we've been used to variables up until now, where you can change a variable. You're not actually changing the variable, you're just using the class as like a template. So Aria said it nicely. When you create an instance of a class, okay, you're creating an instance that has its own, like I say here, independent, which has its own unique attributes. And it's nice because then you can use the class over and over again. Sort of like think of a calculator or even a, suppose a computer. So let's see what else there was. So that we learned how to access a variable. So you take your object name, which was, what was it? But students. And then, for example, we said top 100. That was to access a variable. To access a function, then it would be similar, but you would just refer to your object name, right? So dot, and then let's say number, and then don't forget your brackets. Because we are accessing a function, and your brackets serve as your arguments. And then last but not least, we learned about the initializer. Okay. And our init, which looks like this, okay, it's used when we initiate a class. When you want it, when the object is ready to be used, but it needs to start somewhere, then we can make use of the init. So let me just check here. So what happens with the init is that a method in classes, a method being probably a function within a class. I suppose it could be anything, even a simple math sum, right? within a class is automatically called right, when an object of the class is created. So remember, up until this point, we were used to first having to create an instance. So bit students, then we had to refer to the name of the class, right? Bitcoin faculty, right? Whereas now using the initializer, you can basically assign or initialize it immediately. So you would say bit student equals, and then refer to the name of your class. And let's make it 1,000. So that's in a nutshell what the initializer does. We saw it was actually more convenient. Look at this example here. Let me switch back to my normal screen. You look at the exercise, right, where we had to go name, kind, color, value. And then even down here, there was so much more writing involved. First, we had to initialize the class. Then we had to go down name, color, kind, value, and then you still had to do your print. Whereas if you look at the other example we had, look at how much shorter this code is. Ignoring the comments, right? We can, okay, so we still had to use the make model here and the reading, okay? But as for here, it saved us all of this writing because all you had to do is put in the information here in our initializer, which is basically a function. So, yeah, I think that's it. Guys, I hope you have a blessed, lovely weekend. Stay safe. I know today was rough, but yeah, it's good. We're getting there. Only 2 more lessons to go before we've covered fundamentals. I'll see you in the next lesson.